Hello student, I will start a new lecture. This is software defined networking. Uh, software defined network, and the unit 1 is related to basics of software defined networking. And well, today I'll discuss about what is software defined network, how it is different from the other networking and some other part of the networking. Uh, Before going to the software defined network, first I want to tell about the what is networking and what is the traditional networking. Networking means if you want to communicate one device to another device, so for that you need a one hub. This is called as a networking. Communication between the each and every device through the hub. This is called networking. So here, when whatever information we are going to send from one system to another system, first it will send in the format of the packet. There are the various layers through this the each and everything will perform. Suppose if I have one system, one computer, if I want to send an email from my computer to the another email in another system, it will undergo through different steps. And normally when the data will transfer, that normally it will transfer in the form of the packet. In the network there will be one data plane and the control plane, and there will be switches also. Switches, these are also called as a router, which will one is router, another is switch. Router means it will find the different path through which the data can be transferred to the particular destination. And switches means which is used to transfer the particular packet. And we have seen that in LAN, Ethernet, MAC address, IP address. The IP address is normally to define the particular path or particular destination, which address the data will be transferred. So for that we need to define as a IP address or Internet protocol. MAC address means in our my system there will be a particular address to define the my system. So for that this is called as a MAC address. MAC address related to your system. IP address is related to the network and path and destination where it should go, like that. And when the data will transfer from your system to the wire, so then the MAC address is needed and Ethernet cable is needed. Ethernet cable is used to transfer the data from one system to another system and one system to router which connects many computer. Okay, so I'm while discussing many things, we'll discuss this term. So I'm not discussing too much about the other part, which is not too much relevant with this topic. Now come to the traditional network. The traditional network, there is a control plane or there is one more data plane. The control plane normally is used to see how many paths are there and to take the decision which will be the best path and where through which path the data should be transferred. So those kind of the thing can be decided by the router. And there is a switch which will be there inside the data plane. So data plane will be resides, the switches will be reset into the data plane. The data plane work principle is to transfer the data. Once it get clearance from the router or control plane, then it will transfer the data to the destination hub. So this is about the control plane and the data plane. The traditional network, it's a older network which connects the hardware with the which connects many hardware like routers, switches, and the infrastructure. But here in every data plane there will be a, or every device or every switch there will be a control plane in the traditional network. So everything they have to do through the manual configuration. So this there is a switch. The switch can control, switch will be reset into the data plane. Switch will be inside the data plane. So it will transfer the packet. Okay, so it will transfer the packet. Now the control plane will be along with the switch only. So it will related to router. The control plane will be related to router. So there is one more switch associated with this switch. There will be one router. Okay, so in this router switch. So through this switch, the particular data will be transferred. Okay, so while transferring the data, if there is a failure in this path, the router will see those things and it will get the information to the switch. Okay, so this is a path you cannot go and too much traffic is there. So such kind of the information will be updated into the router. This updation will be done through the routing through the manually, and the destination IP address, source IP address, everything will be there in the control plane. After those information also will be there in the switch for checking any data enter. So when the router will give the decision, okay, the data can transfer through this switch, then the switch will check everything, the destination IP address, everything. So I'll come this in the upcoming lecture. So here the control plane, which the networking related information will be there in the control plane, and the data related information will be there in the data plane. For traditional network, each switches which will be there resides into the data plane, which have the each control plane. So for any configuration change, every control plane and data plane should be changed, and everything should be done manually. It's very difficult. If we have the many amount switch nowadays, we have to need the large network and many switches are needed. So for that, it will be very difficult to control all the control planes. So that's why better integrating different control plane into different data plane. There is a decision take handle where the one control plane will be there that can control all the data planes. Okay, so this is called as a centralization. So in the software defined network, there is only one control plane and everything will be controlled manually, not manually. It's through the software, everything network related management will be controlled. So the complex management, so if you have the multiple control plane, very difficult to manage, and anything happen in the particular data plane, control plane or data plane, very difficult to manage, difficult to scale. Difficult to scale means if we need the 1,000 switches for 1,000 switches, 1,000 control plane. The 1,000 control plane will take the different decisions. So if you want to integrate any switches with the another, it will be very difficult to achieve the ambition. So that's why the difficult to scale. Vendor dependency. Vendor means, so for multiple control plane, you need to coordinate with the multiple companies and the vendor. So there's a vendor dependency. High maintenance, because if you have the more devices, slow configuration. So each and every control plane you have to configure. So if you have the multiple control planes, so these are some problems which are there in the traditional control plane. That's why software defined network come into the picture. So where everything the network is controlled by the software and there is one controller. So here you can this one switch and this internet, and this is one switch, and under switch there will be multiple infrastructure and there will be multiple routers. So controller will decide through which path it has to take from one source to destination. Okay, so these are the just through this the data can be transferred. But the first controller will check all the path which are there between source to, this is the source, suppose this is the destination. Source to destination, it can see the overall view of the networking path. After that, it will decide the network related which path it has to take to reach from the A to D. Okay, there are many, but if any failure in the other path, it can take the another path which can be decided by the controller. Okay, the software defined network is a networking approach where network is controlled using software instead of hardware configuring. Right? So there is a one centrally controlled plane. Okay, so it can using the software, everything is configured, and there is a one centrally controlled plane. Okay, so this is about the software defined network. If you compare both the network structure, now you can see every system device has every switch, and every switch there will be a control plane. Okay, but in case of the SDN and architecture, there is only control plane which is controlling all the switches, simple forwarding. Centralized control, and it can be programmed using software. here each device should take the decision. Each control plane take the decision about each switch. Here only one control plane take decision about all the switches in the SDN architecture. So centralized control, programmable network can be programmed using software, easy management, automation, everything is controlling through the software. That's why it is called as automation. Better scalability and flexible means, and you can connect the thousands number of switches which can be only controlled by the only one controller. So that's why it is the better scalability. Scalability is huge amount of the device you can connect with the help of the only one SDN controller. So these are the some features of SDN network. Now first we'll discuss the architecture elaborately in the upcoming units. So here the main three parts are there in the SDN architecture. One is the application layer, control layer, and the infrastructure. Infrastructure layer will have all the routers, switch, and hub, and the controller layer which will have the information related to networking and all the network and all the paths related information, and there is the application layer. So net controller itself cannot take all the decision. Sometimes it needs to take application from the some higher authority. So this is called as a application layer. So controller layer sometimes it cannot take. Some rights will not be there in the controller. Controller can see the path. Okay, so I have the many paths to reach the see for this one there is a city Chennai and there is a city Bombay. So controller can see like a GPS. It can see the path. Okay, so there are the multiple paths to reach from source Chennai to Bombay, but which path will be the shortest path? That calculation cannot be done by the controller. It can be only possible by the application layer. Okay, so application layer only can control the only calculate the path, best path, and any heavy traffic is there or not in a particular path. Okay, the equal amount of packet should reach in the all through the all the paths. So those kind of the calculation can be done by the application layer, and application layer will pass those information to the controller. After seeing those information, then controller will take the decision which path it has to follow. The packet has to follow which path, and then it will inform this to infrastructure layer or the data plane, which from where the packet will be transferred. The communication between controller and application layer is called as a northbound interface, and the communication between control layer and the infrastructure layer is called as a southbound interface. Why we have need SDN? So these are the some features for that we need SDN. If you want to design a large network, if you want to establish some cloud computing, if you need a data center, means huge amount of data can be stored. The data center for faster management, low cost automation, for such kind of the feature if you want to develop, for that you need the software defined network. So evolution of the network is when before coming to the software defined network, there are the many switches are developed. After that, the software defined network concept is came. And so software forwarding. Software forwarding means the packet is forwarding through the software. Okay, so CPU is there. CPU is used to transfer the packet. So that's why it is the software forwarding. Then independent device. Each device has a one control plane and the data plane. Then hardware forwarding. Hardware forwarding means the hardware is used to forward the data. Okay, hardware is used to forward the data. After that, the technology design hardware plus software means software is used to manage the network and the hardware is used to transfer the data. After that, from the software, each device has the each software and hardware technology. After that, the controller came, centralized controller. Thus, network is done through the software, but there is only controller and there are many data which are hardware only. So this is the final one. In this way, the network devices are designed day by day. So there are some costs which can be minimized with the help of the SDN, development cost, operational cost, hardware dependency, but it benefits there's a development cost is operational cost and maintenance means if any failure for the maintenance cost will be very less. It will be reduced as the number of devices is reduced. Hardware dependency. So only one many switch only depending on the only one controller. If the traditional network, the many switches are depending on the many control plane. So hardware dependency is also reduced. So it can further improve the automation and the resource utilization. So there are some advantages already I discussed in easy configuration, high scalable, better security, traffic optimization. So if one controller can see the many paths, so it can calculate the traffic or data. Suppose in there is a path where the many packet is transferring, so controller application layer and controller can calculate everything, and the packet will transfer through the another path where the packet is there is a less traffic. So traffic optimization is also possible. So there are the many features which can be possible in the with the help of this SDN. So for